So welcome everybody. My name is Jeff DiCorpo, and I would like to welcome you to this webinar titled Getting Started with ChipCreate. So we're super excited to have you here. I'm joined by my colleagues, Mohamed, Kassem, and Marwan, Abbas, who are on the call with us, and they're going to be helping. Marwan is going to be presenting some content earlier in the middle of the session, as well as Mohamed is going to be available to answer questions as well. We're going to go over a few topics related to ChipCreate, including kind of a little bit about the company, a little bit about the ChipCreate program, as well as talking and showing you some specific pointers in terms of how to get started, integrating design, kind of running pre-check and submitting your design. And then finally, we'll also touch on a few features that are available, that we're providing available as part of the shuttle program, including SRAM and ReRAM. Just as a note, the webinar is being recorded, and it will be sent. A link will be sent out to all participants who registered, including a copy of these slides as well. We definitely encourage questions. I'd love to. We're going to be answering some of those as we go, asynchronously, but also we'll take some time at the end of the webinar to walk through and cover some of the questions that you submit. That you have. So please submit your questions. We're using the Q&A feature in Zoom. So there should be a button at the bottom of your Zoom interface for Q&A where you can post your questions there. We're also looking for and interested in any feedback you have on future topics that you'd like to see covered in subsequent webinars that we're going to be doing. Okay, so with that, let's go ahead and get started and talk about a little bit who is Chip Foundry. What is it? So Chip Foundry is a new business with a goal to continue the momentum developed around the expanding the access to chip design and innovation. And as part of that, providing the path, design, and fabrication based on the open source Sky 130 PDK introduced back in 2020 by eFabless, Google, and Skyware Technologies. So Chip Foundry has launched the ChipCreate MPW program, which kind of builds on the experience kind of gained from previous open source initiatives. Among the founding members includes myself, Jeff DiCorpo, and Mohamed Kassem, both of us formerly with eFabless, and we're also joined by a third member, Samir Patel, who has had a long history in the semiconductor industry. There are also a handful of others helping us as well. Marwan, Abbas on the phone with us, who you may have interacted with, as well as a few others that are helping us as we're kind of getting started and trying to rebuild the program. Because I've had received several questions in the past regarding this, just to clarify, Chip Foundry is building on the eFabless open source legacy and kind of the open source content that was created and published by eFabless, but it has launched an independent business and doesn't have any formal or legal relationship kind of to that former company. Okay, so let's move on and talk a little about what is ChipCreate. So ChipCreate is an end-to-end solution that provides everything needed to design and fabricate and test your chip. It includes a selection of SoC platforms and pad frames that greatly accelerate kind of the time to implement a chip. These are basically pre-built devices that provide a large area to insert your own custom digital analog logic. They include configurable I/O that supports a range of digital and analog signaling, and the solution also includes pre-designed packaging for based on QFN parts, but it also provides options for bare die or the option to kind of get all bare die if you choose that path as well and you want to do your own packaging. You also get an evaluation or development board with some of your parts already pre-assembled onto the PCBA. And so it's kind of provides a kind of easy way to get started and includes test software and code examples that can be extended to kind of greatly assist in bringing up and testing your design once you get it back. You also get an expanded access to an expanding library of IP and reference designs that kind of provide building blocks and ways to kind of get started in terms of implementing your own design in the user area. We're going to talk about a few of those things at the end of the webinar, including the SRAM. This is all kind of provided in a very simplified pricing model. Everything's kind of included for a single base price. That price is $14,950. And our next shuttle is coming up in September 16th. So we encourage you to check it out if you haven't already. And you can learn more about that on our website at chipfoundry.io. All right. So just to kind of touch a little bit further on the SoC platforms, if you're not familiar with those, they're namely those are Caravel, Caravan, and OpenFrame. In addition to kind of providing all the infrastructure for power and I/O, Caravel and Caravan also provide a complete RISC-V microprocessor with a clock, memory, flash controller, and a set of standard peripherals. It also extends a wishbone bus and logic analyzer probes into the user area for integrating with your design. It allows you to kind of drive or probe signals kind of for elements within that you implement in the user area. Caravel is kind of the standard template and supports both digital, analog, and mixed signal designs. Caravan provides a set of bare pads without any ESD protection, and those are really intended for customers who have requirements, that may be high speed, high voltage, or negative voltage signals. They're really aimed at like prototyping within a lab environment where you're controlling ESD concerns for your end relative to your design. OpenFrame itself is a third kind of one shown there. It does not include an SoC, but it provides basically an entire area that can accommodate larger designs. It does require more knowledge because in order to properly configure and use the I/O, as it does not include any of the logic from the SoC that's used to configure and manage that for you. All right, so I'd like to transition, maybe talk a little bit about kind of an overview of the business process and submission process and a little bit how that works. It starts off kind of with design exploration, kind of shown on the left. We're going to discuss more of the specific steps around that coming up here in the next few slides that Marwan's going to cover. But basically, as you're working through that and you reach a point where you're ready to secure a spot on the shuttle, you can do that by placing a $500 deposit. That basically ensures that you have space on the shuttle for your project, and you can find links to pay for payment via credit card from our site in order to do that. If you need another option, please contact us or reach out to us, and we can provide you other options as well. From there, you will need to provide a 50% deposit by the commitment date for the shuttle. So the commitment date is typically about 60 days prior to the submission deadline. For the September shuttle, that commitment deadline is July 18th. These commitment deposits ensure that we have the minimum number of projects to cover the costs we need to pay the foundry and other suppliers in order to support running the shuttle. So we will be continually maintaining updates and status of the shuttle and whether we pass this kind of no-go milestone. And at the latest, we're going to notify everybody within a few days after the commitment deadline, or earlier if we reach the required number of projects prior to that. You can yourself go off and check like where we're currently at. By checking our website on our homepage. There's a link here shown that will take you directly to the metrics on our homepage section. Once confirmed, you will be required to provide the balance of the payment within 14 days prior to the shuttle deadline. And then the delivery of your parts and boards are delivered approximately 5 months from the submission deadline. And for the September shuttle, that basically is in February. So in the event that the shuttle does not proceed due to not having enough projects, we will provide a full refund for all money paid, including reservations and commitment deposits. You will also have the option, if you choose to carry that forward into the next scheduled shuttle, if you want to continue forward. So our goal in general is to try to provide as much transparency as possible, so you are fully informed in terms of kind of the status of the shuttle and how close we are in terms of meeting those goals. And in addition, if you are a university in the United States, we do have an option to support milestone payments based on requirements for your institution. And if you're interested in that, please reach out to us at info@chipfoundry.io to learn more about that. So, but with all that said, I'm extremely happy to report that we've had a very positive response and the demand and demand to date. We've actually met the requirements we need to go forward with the September shuttle. So at this point, we are announcing an early go decision for September. That means the September shuttle will proceed based on what we have already to date. Okay, so I think that covers it for now. I'm gonna switch over to Marwan. He's gonna go into a little more details around how to get started with your project.
Yep. Thank you, Jeff. So I'm gonna be showing you how to start a project with Chip Foundry. So to start a project, you need basically three basic requirements. So you need a Linux machine. This is a recommendation. You can run the flow through Mac OS or Windows. With Windows, you need WSL. But this recommendation is because you need Docker on your machine. And that's the second prerequisite, which is having Docker on your machine and a GitHub account. And to start your project, you need to do three simple steps. So create a public or private repo from one of our templates. So we have GitHub templates for each of the SOC platforms that we have. So Caravelle, Caravan, and OpenFrame each has a template on GitHub. So from there, you can create your own repo. It can be public or private because we support both open source and closed source designs. And then you clone that repo and you set it up locally. And we're gonna show you a video on how to exactly do that. So first of all, we do have a page on our website on how to start a project. So it's going to take you through all the steps that you need to start a project. So we're going to be doing that. So we're going to look at the template for Caravelle user project, which is like the template you would use if you're going for the Caravelle SOC platform. So from there, you're going to click on the use this template a button and create a new repository. So that can be created under your own account or an organization account. And then you name it with the name of your project. So for example, here we're going to name it demo project. And as I said, it can be public or private. So that's going to be your choice. But for this example, we're just going to do a public project. So yeah, as you can see here, it's going to create a repo under your own account or your organization's account. And from here, you can actually just copy the GitHub URL for your repo and go to your terminal and do a git clone and then paste that URL. And that's basically going to download your repo locally so that you can start your project. So the first thing is actually going inside your project directory. And then we're going to look at the next step in our page. So it's going to be a make setup. So we can copy that from here and paste it in the terminal. Yep. And that basically is going to be downloading all the requirements to start your project. So that that means that it's going to be downloading the PDK. So our like the Sky 130 PDK is open source. It does not need a license. It does not need an NDA. And through that command, it's actually downloading the PDK and downloading other tools that you're going to be using throughout your design process. And now we're just going to show you the directory structure. So the two main directories that you really want to be looking at are the Verilog directories and the OpenLane directory. So we're going to start with the Verilog directory. So here we have the RTL directory inside the Verilog directory where you're going to put your RTL code inside it. We do actually have an example there. So just to show you, this example is actually a 16-bit counter. And we're going to show you throughout this this webinar how we actually implemented the counter and integrated it inside the user project wrapper. So this is the RTL for the counter, and then now we're gonna see the RTL for the user project wrapper, because you do need to integrate your design inside the user project wrapper. And this is basically where you're gonna be integrating your your design inside the user project wrapper. So let's go back here. So just to get into more details, as we saw, like there's a Verilog directory, there's an RTL directory, and inside you're gonna put your RTL code. The point that I really want to show is how you integrate your actual design inside the user project wrapper. So to integrate it, you need to hook up your design to the user project wrapper. That would connect to either Caraville or the SoC, the RISC-V processor, or with outside world. So the first thing you want to do is actually connect the power and ground pins to your design. And then if you're going to be using the RISC-V processor and doing any processing, and you are going to do that using the wishbone bus, you want to hook up the wishbone pins. And if you're going to use logic analyzers, we do have 128 pins for the logic analyzers. So you want to hook up that. And then if you're going to be interacting with the outside world with the pins that are actually on the board, you want to connect those to the GPIO pins that we have on the user project wrapper, which would directly connect to the pins on the path frame that connects to the pins on the board. I did mention the OpenLane directory. I just wanted to quickly show you what OpenLane is. So OpenLane is a tool. It's an open source RTL to GDS compiler. So basically, you would give it an RTL code and a OpenLane configuration file, and you would run through the flow. This flow basically takes your RTL code all the way to a GDS file. So that GDS file is actually what you submit to us. And then we take that GDS file, we integrate it inside one of the SoC platforms, the one that you chose basically, and then we send it to the foundry. So this is basically what the foundry takes to start manufacturing your custom chip. I wanted to show you how the configuration file for OpenLane looks like. So inside the directory structure, you're going to find an OpenLane directory and a configuration file for each macro. So for example, here we have the example macro and the configuration for it. So the first thing is the design name. So here, you don't need to really change the design name if you don't if you don't want to, and actually it's going to make it much easier if you don't change the name, but if you do want to change it, you can change it through that variable, and then if you have more RTL code and you didn't just change the code inside the example, you would point to those RTL files from this variable. And then if you're going to change the name, you would need to change the name in this path as well. And then if you want to change the size of the macro, you would change it from the die area. And if you want to change the pin locations for the macro, you would change it from the pin order file. And then to integrate your example inside the user project wrapper, you would need to integrate that. You would need to change the configuration file for the user project wrapper. So the first thing is to actually place the macro. So there's a macro.cfg file. In that file, you would put exactly where you want the macro to be inside the user project wrapper. And if you did change the name of your design, you would need to change all of these paths. And if you have more macros, you would need to update all of these paths to have more files in them. And yeah, so we're gonna do a quick run on how to actually run OpenLane. Okay, so running OpenLane is really easy. So it's you would do a make and then the name of the design. So for example, here we have the user project example. So we do make user project example, and that would basically go through the whole flow, and it would generate the GDS for the example. So, and then the next step is that you would need to actually harden the user project wrapper. So that would actually integrate your example inside the user project wrapper and hook up the pins from the example to the wrapper. So that's going to be done using the make user project wrapper. And we'll let it finish here. So yeah, so now you actually have a full design. So you have the example that's integrated inside the user project wrapper. And now we can see actually how the GTS looks like using K-layout. So yeah, let it load here. Okay, so this is exactly what the GDS looks like, or the layout looks like. So here we have the counter. So this is like this green box is actually the counter, and this is the wrapper. And this wrapper is basically what we integrate inside Caravelle. So and it gets connected to Caravelle. So so yeah, so this is how it looks like, and this is how we send it to the Foundry. Okay, and finally, the last step is pre-check. So pre-check is basically a series of checks that runs on your design. We do run pre-check locally. So pre-check checks that your design can be manufactured and can be integrated inside one of our platforms. So we're gonna just cover the main important checks here. So there's the DRC MR checks, which is like the design rule checks for manufacturing. And this basically makes sure that your design abides by all the Foundry rules for manufacturing. And actually, if you are actually running OpenLane, you wouldn't need to worry about that, because OpenLane does run a DRC through the flow. So there, you most probably won't have any issues. But we do run it multiple times just to make sure. And then we run the LVS checks, which is layout versus schematic. This makes sure that the layout is the same as the generated code from your RTL, or your netlist that was generated from your RTL. And then we have the output enable bar checks, which makes sure that that you hooked up the output enables correctly, so that if you're intended to use the pin as an output, it is actually enabled. And if it's an input, it's not enabled. And then the next check is the GPIO defaults check. This makes sure that you configure the defaults correctly. So we have a file that you can configure your GPIOs input, output, or bidirectional. So we do need you to have a default, but you can change it through firmware if you're using Caravelle or Caravan. And then we have the XOR check, which basically makes sure that your design fits inside one of the platforms. Okay, so we're gonna show you how to run pre-check. So yeah, that's also in the page for getting started. Okay, so the command is basically make run pre-check. So this is gonna go through all the checks. So there are more than the 5 checks that we were discussing, but these were the main 5 checks. And now we're gonna see that by the end of the flow, it's gonna tell you if there are any errors or failures in the flow. And now we're gonna show you exactly how to see those issues. So there, as you can see here, there's a new directory that got created called pre-check results. And inside that directory, there's all the logs for all the steps in the flow. And there's the main log, which is called precheck.log. Here we're gonna look at it just to make sure of all the failures that happened. Yeah. And there are also reports. So we're gonna take a look at a report right now. We're gonna look at the LVS report. And starting from there, we can start debugging the issues and fixing them. And of course, we're gonna have more videos and more articles on how to exactly fix those bugs, how to look for the bugs inside each report, and so on. And yeah, and we're definitely gonna be putting out more videos and webinars on how to run OpenLane, how to do maybe a more complicated design or more complex design. So something like multiple macros inside the user project wrapper, or how to run verification. So yeah, we're gonna be putting out more articles on that for specifically for more complex designs.
All right, back to me.
Yep.
Excellent. Yeah, thanks, Marwan. Appreciate it. So hopefully, for some of you that have already had history doing projects using the OpenPDK and submitting those through eFabless, this all looks very familiar. Just to confirm, we are using the latest versions of Caravelle, and any previous designs that you have done which should be compatible if you kind of with what we're using to support the shuttle. I wanted to provide a few key points regarding kind of submitting your design. So first of all, we are going to be providing some more specific steps here kind of in the near future in terms of kind of the steps you require to actually submit your design files. This will entail either one of two things: either providing us access to a GitHub repo that your GitHub repo, or providing you a means to upload your files through our website, design files to the website. So with respect to that, there's only a specific set of files required for submission. Namely, you need to provide us the GDS for your wrapper that Marwan showed. So that's either going to be, depends on the SoC platform or frame you're using. There'll be a kind of a different file name for that. Also, you need to provide us a user defines file. And so the user defines file, if you're familiar with Caravelle, basically sets the configuration for all the I/O on the power on reset condition. So that's kind of a design time decision in terms of how you configure the I/O. Of course, you can, if you're familiar with Caravelle, you know that you can also go in at runtime and also reconfigure those I/O using either the RISC-V processor or through like a housekeeping interface available through the platform. Each of those files do need to live in the respective directories. We do automate, like all of the processing of design files are kind of automated through, and so we do expect to find files in specific places. You do have the option to compress those files if you'd like to. You can we can accept files using like gzip. And then, of course, as Marwan just showed earlier, you should have run a successful pre-check and make sure that your design passes pre-check. If you have questions on that, please feel free to reach out to us. Once we do have received your files and we've processed your design, we will be sending you confirmation email to confirm that we've received everything and everything completed successfully. All right, so moving forward, I'd like to talk a little bit about SRAM. So as you may have seen, we are offering SRAM macros for implementing in your user design area. So these macros are they're similar to they're related to basically the same macros that we were offered previously through eFabless. They are commercially proven. SRAM macros have shipped in billions of units, and we're providing kind of 3 configurations for those to make it easy to use. That have a range of different sizes, starting from 1024 up through 8192 times 32 bits configurations. Each of those macros are wrapped with a wishbone bus interface, and so they can be readily dropped into the user area and connected up to support kind of applications or designs that you want to implement. The price for using those macros in your project is $2,500 per project. That said, you can implement as many macros as you want in the user area for that single price. So we will be providing more instructions on how to access and implement those macros. That'll all be available through IPM, which is a tool used for managing and installing IP in your projects. Okay, thanks, Marwan. Let's move on to the next one. Talk a little bit about ReRAM. So we've had a number of people ask about, and so we were super pleased to announce that we're supporting ReRAM for the September shuttle. We've been able to kind of finalize all the specifics required with Foundry in order to offer that. Normally, the price of ReRAM would be $3,000 per project, but as a special promotion that we're running for September is we are waiving the cost. So all you need to do to take advantage of that is to provide your 50% commitment deposit by the deadline, July 18th deadline that I mentioned earlier. If you want to learn more about that, you can find more information regarding the technology on our website. We have a landing page for ReRAM, and in there is a link to the detailed documentation around the technology. We're also happy to announce that we're going to be making available some SRAM macros based on that same technology through a partner of ours, BM Labs. We're going to be kind of sending more information about that soon, but that makes it an easy way for you to take advantage of ReRAM and provide non-volatile memory for your project without having to build the technology from the ground up yourself, or build a macro for yourself. Okay, so moving on to the last thing, I'd like to make special mention is we're super proud to announce continued support for fabrication of the Tiny Tapeout program, including on the shuttle coming up in September. Tiny Tapeout, as many of you know, has made a huge impact on the industry. It has enabled access to chip design to hundreds, if not thousands, of individuals globally. We share a common vision and passion for open access to chip design. And so, as part of our partnership and sponsorship, we are subsidizing the cost of fabrication for a portion of the Tiny Tapeout projects that get submitted through the ChipCreate program. So please keep an eye out for more information from Matt then at tinytapeout.com. Okay, I think that about covers it. So with that, we'd like to maybe transition and cover any Q&A. So please, again, if you have any questions, please submit those through the Q&A facility using the button below on the bottom of your Zoom interface. Let me just go over, I guess, a couple that we've already got. Okay, so one of the questions that we had was, is there a list of capabilities for each of the frames and their I/O pins, such as max clock speed, bandwidth of pins, and pin-to-pin delay? So we do have some of that information is covered in the data sheet for Caravel. I provided a link to that, but you can find that in the docs directory under the Caravel repo. And so on GitHub, you'll find a chip foundry organization. You'll find copies of Caravel and Caravan and OpenFrame repos there that we use and within there you can find the documentation I just mentioned. There's also another document that kind of goes into details around the registers, around each of the registers for the SoC, for the RISC-V SoC. In terms of pin delays, that's available in the I believe in the SDC files. And so we'll provide you another follow-up link in terms of where to kind of get more of the specifics around that. Correct. So Mitch, go ahead. Marwan, you want to cover the next one?
Yeah, sure. So first of all, hi, Mitch. Mitch is asking user defines.v is only necessary for Caravel Caravan, right? I don't think it's needed for OpenFrame. That correct. Is correct. Yes. You only need it for Caravel and Caravan.
Okay, so in terms of primary source of information for the community, Discord or Fossey chat. I wish I had an easy answer for you there. Right now, we're straddling a lot of fences, a number of fences. We're trying to provide information out through both. I will see how things continue to evolve, but you know, right now we're kind of providing, but we're providing information out both of those. So it really comes down to whatever you're more comfortable with. Myself, I find I've been using Discord for some other things as well, so I tend to be using that a little bit more. But it's really up to you and what's easier for you. So we're going to be providing both information via like Discord or Fossey chat, as well as we'll be posting information via email as well to people who are subscribed to our to the updates on our website. If you haven't done that already, if I'm assuming that's probably how you heard about this in the first place, but if you haven't done that, I encourage you to go to our homepage. At the very top, you'll see sign up for updates, and that will keep you in the loop on any new things that happen relative to the program. Is there another one, Marwan?
Yeah, so there's a question. Can I specify the input and output delays to constrain the setup, hold, and clock data delays for my RTL?
Yes, I believe you have a comment on that.
Yeah, so you can do that, but we recommend that you don't do that for the wrapper itself, as the wrapper is going to be integrated into a platform. So for example, Caravelle, and that would mess with the whole timing of Caravelle. So just make sure that you are using the SDC file for the user project wrapper, but for your inside macro, you can change the constraints.
Yeah, and then also any signaling that goes directly to pads, right? Obviously, if you have specific timing requirements there, you would need to modify and update your constraints accordingly, right? But
Exactly.
but the template does come with, as Marwan mentioned, it comes with a timing constraints that have a budget associated with the Caravelle, right? So for all the signaling that goes back and forth to Caravelle, that's already predefined for you, and you just if you utilize those constraints, you'll ensure that you get good timing closure for your macro within the overall chip. Okay, moving on. What is a target node technology? Okay, so the target node technology is so if you're we can probably provide some pointers to this as well if you're not familiar with it, but it is it's called Sky 130, but it's basically a 130 nanometer node from Skywire Technologies, which is a foundry in the United States. And they that is part of an open, it's probably one of the few fully manufacturable open source PDKs that are available that you can go out and download and use without requiring an NDA or any special legal requirements. And so that is the technology that the shuttle's basically supporting, and you can provide more information about that. We will post something and make something available on our website as well for people who want to learn more about that specifically. Okay.
There's another question by the same person. You will only receive the GDS pre-checked by customer, or you will do extra checks to sign off?
No, we're going to do extra checks. So we do final verification checks. So what we'll do is we'll take your GDS, we integrate that with a golden copy of Caravelle or Caravan or OpenFrame, depending on which one you're using. And then we have to run additional data prep, including fill generation. Once that's all done and finalized, and we add seal ring, of course, around the overall die. Once that's all completed, then we run final checks. Now, we expect all those checks to pass if you pass pre-check, but we do run another set of checks to confirm that there's no DRC errors or any other violations in the overall design before we submit to the foundry.
Okay. The next question is, will the ReRAM be available in the next MPW?
Yes. Right now, it's available in September, and for in the subsequent, we're currently planning to provide it in the subsequent shuttles as well, but definitely for September.
Yeah, and for September, it's free of charge.
Correct, and there's no additional cost in September too, so there's another advantage to do something in September if you're able to do it.
Yep. Next question, are there any plans supporting more technology libraries, example, global foundries?
Questions have come up. We got our plate full right now, just getting restarted with the current technology with Skywater. So at this time, we don't have anything defined or not or to be announced, but right now, but that is something that we'll continue to look at going forward as we get further.
Last question is, once manufactured, is there any restrictions to send the devices to specific countries such as Mexico?
No, they're just that we do require that people complete an export certification. And we'll be providing information on that here shortly, but it's basically a certification that your design complies with any or doesn't, yeah, it does complies with any export restrictions. In general, most of the design, like most designs on this technology, with few exceptions, would comply with export regulations, but you need to kind of confirm that because we don't know the specifics of the design and what you're implementing. But in general, there are not, the only restrictions are kind of the general restrictions at a kind of a global scale in terms of specific countries that we're not allowed to ship to, not allowed to ship. U.S. is not allowed to ship to. So, but that's a limited list that has been around for a while. But in general, we generally don't have restrictions around, countries like Mexico in terms of shipment. Okay. Definitely, if you have any other definitely any other topics that you're interested in seeing, things that we didn't cover or that we didn't mention, maybe coming up in the future videos, please feel free to either reach out, and you can drop us a note at info.chipfoundry.io. Yeah, I see there's another question that came in, so maybe we can cover that as well.
Is there a transition path from prototype into a custom die package?
Yes, we'd be happy to talk to you about that. So definitely just I would recommend reaching out to us again, an email or via one of the Discord or Fossey chat, and we'd set up a call to kind of talk through specifics of how that would work or what you want, depending on what you're trying to do.
Okay, there's if we have an IP we would want to integrate in our design and also want to offer to others, how to do?
Okay, great. So we are, as I mentioned, we mentioned earlier about kind of a growing library of IP that is going to be available through a marketplace model, where we're going to enable a path for not only to provide access to IP that from either open source or outside parties, but also provide a means for people to make their own IP available to others to use, and either as open source or for charge if they want to monetize that. We are going to in the future, kind of near future, we'll be kind of reaching out or providing more information about that program and how that will work. But in the interim, if you have a specific interest, please just reach out to us directly, and we'll set up a call and go through that with you.
Okay. eFabless had a service called ChipIgnite Mini. Do you plan to have a similar service?
We are looking at that. That is something that, well, right now we haven't taken that on for the first shuttle. Definitely that template, however, is available. So if you wanted to, if you wanted to integrate multiple designs yourself and share the cost with other individuals, or you're doing that as part of a class, those options do exist, and we can basically take a GDS with those integrated designs, on the shuttle. We just don't have today. We just don't have a product offering or solution to kind of basically take individual pieces and integrate them. At least not for September, but it's something that we are continuing to look at. And if you have an interest in that, we definitely would like to hear about it, because as we understand more the potential demand, that gives us a better sense of our ability to kind of support it.
The IP in the marketplace will include analog or mixed signal designs.
Yes.
IPs, sorry.
Yeah. So there's analog and digital IP in there. And yeah, some of that will be mixed signal because it's going to have digital interfaces or digital wrappers around analog.
Okay, I think that's it.
Okay. So if there, so no more questions. Again, I want to thank. We're going to go ahead and wrap it up here. Again, I want to thank you everyone for attending today's webinar. Please don't hesitate to reach out to us. Love to talk to you, and look forward to hearing from you and discussing your project needs. Thanks, everybody.
All right. Thank you, everyone.